Let us look at a function f of x defined on the closed interval minus L to L. Till now, we have been looking at minus pi to pi or some other interval of the same period, that is 2 pi. Now, let's look at minus L to L. Now, either the function is periodic of period 2L or we extend it periodically outside this interval by defining f of x plus 2L is equal to f of x for all x. Now, to work with this period, let us scale it to the interval minus pi to pi. That is a 2 pi period. So, let's do this. Let's say 2 pi is equal to k times 2L, which implies pi is equal to kl. Or we can say k is equal to pi by L. Now, let's say t is equal to k times x, which implies t is equal to pi by L times x. So, which means x will be equal to Lt by pi. So, this is the scaled version. So, our function becomes f of Lt by pi plus 2L is equal to f of Lt by pi. Let's combine these two. We get f of Lt plus 2 pi L by pi is equal to f of Lt by pi. Now let's take out commonalities. F of L by pi times t plus 2 pi equal to f of Lt by pi. So f of Lt by pi is a function with period 2 pi, which implies that f of Lt by pi can be expanded to a Fourier series in the interval minus pi to pi. Here, remember, we are talking in terms of t. So, f of Lt by pi is equal to a0 by 2 plus the summation from n equal to 1 to infinity of an times cos nt plus summation from 1 to infinity of bn times sin nt. This is our Fourier series multiplying the domain by L by pi. So our domain is what? It is minus pi to pi. So if you multiply the domain, we get minus pi times L by pi is less than or equal to t times L by pi, which is in turn less than or equal to pi times L by pi. And with cancellations, it becomes minus L is less than or equal to Lt by pi, which is in turn less than or equal to L. Now let's substitute t. So minus L is less than or equal to L by pi times t is equal to what? Pi by L times x less than or equal to L. So here again pi and pi cancel out, L and L cancel out. So we are left with minus L is less than or equal to x, which is in turn less than or equal to L. So here t is in the interval minus pi to pi. We have brought it, we have converted it into x being less than or equal to minus L to L. Now, remember, when we do integration for a0, an, bn, the interval is minus pi to pi dt. Now, that dt has to be converted to dx. So, we know t is equal to pi by L times x. Let's differentiate this with respect to x. We get dt by dx is equal to pi by L, which implies dt is equal to pi by L times dx. Now let's proceed. Find a0, an and bn. a0 is equal to 1 by pi times the integral from minus pi to pi f of Lt by pi times dt. See, when we are in t, we are in minus pi to pi. Let's convert it into x. So a0 is equal to 1 by pi times the integral, the interval becomes minus L to L when we are converting it to x. L by pi times t. T is x pi by L times dt is pi by L times dx. So this is what a0 becomes. Now let's simplify it further. A0 is equal to pi by L, we can take it out. of the integral. So 1 by pi times pi by L times the integral from minus L to L of L cancels, pi cancels, we are left with x. So f of x dx. And finally, this pi and this pi gets cancelled out. A naught is equal to 1 by L times the integral minus L to L of f of x dx. So we have found A naught. Now let's find An. Now An is equal to 1 by pi times the integral from minus pi to pi of f of Lt by pi times cos Nt dt. So again we convert it to x. So An is equal to 1 by pi times the integral minus L to L of f of, again we substitute t, L by pi times x pi by L times cos n, t becomes x pi by L, dt becomes pi by L times dx. So An is equal to 1 by pi, pi by L comes out of the integral times the integral minus L to L of L cancels, pi cancels, x is left. So f of x times cos n x pi by L dx. This pi and this pi cancels out. We have An is equal to 1 by L times the integral from minus L to L of f of x times cos n x pi by L dx. Now Bn. Bn is equal to 1 by pi times the integral from minus pi to pi of f of Lt by pi times sine nt dt. Again converting it to x, Bn is equal to 1 by pi times the integral from minus L to L of f of L by pi, t becomes x pi by L times sine nx pi by L. So t becomes x pi by L times dt is pi by L dx. Again simplifying this, pi by L comes out. So 1 by pi times pi by L times the integral minus L to L of, here L cancels, pi cancels. So we are left with f of x times sine nx pi by L dx. And here pi and pi cancels out. So finally we have Bn is equal to 1 by L times the integral from minus L to L of f of x times sine nx pi by L dx. So our Fourier series becomes f of x equal to a naught by 2 plus the summation from 1 to infinity of an times cos nx pi by L plus summation from 1 to infinity of bn times sine nx pi by L, where a naught is this, an is this, and bn is this. So we have this function f of x equal to minus 1 when x is between minus 1 and 0, and 2x when x is between 0 and 1. This is the graph of this function. Minus 1 is a constant, so it's going to be a horizontal line between minus 1 and 0. And this is a linear part, 2x between 0 and 1. Now, I'm going to directly show you the graph of the Fourier series when the number of terms is 1. So when n is 1, this is how the Fourier series graphs. Now let's take it to 2. Let's take it to 3. Let's take it to 4. Let's take it to 5. Now taken it to 11. See, as I keep increasing the number of terms, it takes a lot more time to evaluate. So as you can see, it converges with the function. Now, yes, of course, there are these, wiggles in between at the, at the end points. That is basically because sine and cos are smooth, whereas this function has discontinuity. That is the main issue here. So that was the Fourier series for a function, the period minus L to L. In the next session, we will actually see how we evaluate A0, AN, and BN and actually arrive at the Fourier series for this function. Let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.